If you or your team is using GitHub and having your database script stored as SQL files, you would like to have an integration with the Snowflake platform. So you can directly access those SQL files within Snowflake and have a fully automated object creation process or enable the DataOps CI/CD for your data project. This video is all about GitHub integration with Snowflake, and it is not just limited to creating repository object within Snowflake. The entire course is hands-on. We will begin by configuring both a public and a private repository, during which we will create and understand various type of objects while integrating Git with our Snowflake. We will learn how to access files available in repositories under main branch as well as under different feature branches. We will explore different kind of SQL commands that can be operated on these newly created object and explore what is this repository stage and how it is different from other internal as well as external stages. We will pay a quick attention about the grants on these objects using RBAC concept. Then we will focus on a synchronization process with remote repository and see how the Snowflake repository stage can be refreshed. Then we will see how to run the remote file and associate a remote file to create a stored procedure. Finally, we will learn the limitations, what works, what doesn't work while working with Git Snowflake integration. So if these topics are on your learning list, stay tuned until the end of this hands-on video tutorial. Welcome to my channel Data Engineering Simplified. For all my demonstration, I will be utilizing the free trial edition of Snowflake on AWS. Make sure to adjust the video quality to 4K since all my recordings are in that resolution. To speed up your learning process, consider increasing the playback speed to 1.25x or 1.5x. For direct communication, feel free to message me on my Instagram account. If you are interested in systematically enhancing your Snowflake skill, check out my premium Udemy courses. So let's start with our GitHub account where I have already created 2 repositories. So this is the name of my GitHub account, which says github.com/dataengineeringsimplified, and I have created 2 repositories. This is my public repository and this is my private repository, and we would see how we can establish a connection between this GitHub account with this repository in our Snowflake. Before we establish a connection between our GitHub account and Snowflake, we need to create a token. And to create a token, you need to click on this profile icon, and from that go to this option setting, scroll down and click on this developer setting, and here click on this personal access token, sometime it is called PAT, and click on this tokens classic. Now here you will see a screen where you can click on generate new token and again click on generate new token classic. It may ask for a password. Enter your password and click on confirm. Let's give a note. For now, I just specify 7 days and you have to click on this repo. And let's keep rest of the things as is. Click on generate token. Now your token is generated successfully. Click on this small button and copy it. If you read this message, make sure to copy your personal token now. You won't be able to see it again. So copy this token and store it securely in a text file. Now let's see what kind of file I have kept into this repository. So if I click on my public repository, I do not have any content other than this readme file. Most of my SQL files are available in my private repository. Going back to my private repository, and if you look into the private repository, I have one SQL script folder and I have couple of files available in this location, and I also have one tag and one release. So we will see how the tag and release works with that, including the branches. So based on the token which we generated, we are going to establish a connection between our GitHub account and Snowflake. So let's go back to our Snowsite web UI. So this is my Snowsite web UI and I am in my worksheet called Git-worksheet. I'm going to switch my role to system admin. And then I'm going to create a database called demo. So here I see my role is system admin and I'm having a database called demo and schema is public, and all the object which we are going to create as a part of Git integration would be part of this public schema. So in this part, primarily we are going to configure the public repository and the private repository, and we will also quickly understand what all different type of object we are going to create and what all parameters are important and optional to create these objects. So if we have to configure a private repository which can be accessed only through credential, we need to first create a secret object. And secret object is a first class object which is going to be stored at schema level. We need to provide type, user ID and password. We are using the GitHub token access, and that's why the type should be password. If you are accessing through any other mechanism like OAuth or SSO, you need to choose a different value for the parameter type. So name of my GitHub account is Data Engineering Simplified, and this is the token which we have generated in the past section. And if you do not know what is your GitHub account name, you can go to your profile, and this is your GitHub account name, and this is the repo name. So let me quickly copy paste. Now before that, let's see if I have any secret object available in this schema or not. So I do not have anything. So let's quickly create this secret object. Now it is created successfully. Now let me run this. So I got my secret object created, and this secret object is created under my public schema within my demo database. After creating this secret object, next object which we have to create is called integration object. And integration object is not a new concept. We create integration object to integrate with our object storage or alert messages or many other things. This is similar to that. And if you look into the parameter, it takes API provider. In this case, you must have a value called git_https_API. You need to provide API allowed prefixes. In this case, it is github.com. If you're using the other repository like GitLab, Bitbucket or AWS code commit, then this value will change, and we are going to cover them in a separate video. And this will be your GitHub account name, which is this one, and then your authentication secret, and in this case this is my GitHub secret, which is nothing but this value will come here, and enable equals to true, so your integration object is enabled. Let's see whether my system admin role can create integration object or not. So I have replaced this value, and now let's create that. So here I got insufficient privileges to operate on integration object. System admin cannot create integration object. Account admin is the only role which can create integration object. If you do not understand the RBAC completely, I would suggest you to go and watch this particular video which covers RBAC as well as tag concept in detail. Now let me drop this secret object because I would like to create all the object from a particular role. So I drop this object, going back and changing my role to account admin. Now let me create this secret object once again. It got created successfully, and let's see, run the show secret command. And this time my owner is account admin, looks good. Now I'm going to create this my Git API integration object which refers to this secret object, and it is good advice that all those objects has to be created with one role rather than creating them with a different role. So my integration object got created successfully. Now let's run show API integrations. So this is my integration object and type is external API call, and this is what the information it shows here. Now, can I run show integrations? Let's see whether it works or not. This also works. Both of them give the same result. Integration objects are not schema level object. They are primarily account level object, and all the account level objects are generally created by account admin and not by system admin or a security admin. So now my secret object is created. My API integration object is created. Now we are going to create a third object called Git Repository Object, and which is a very new kind of object. And this object need to have the reference to your API integration as well as your secret object. And once it is available, then you would be able to refer to your repository through this origin. So origin is nothing, the source code which we have to refer. So now let me quickly create this. Now this also got created successfully. Now let me show you one interesting thing. If I go to this DemoDB, under public, you will see a new entry called Git Repository, and if I click onto that, here my Git repo is listed. This means that this is a schema level object, and this is how it comes onto my database panel. But can I see the same entry when I go back to my database screen. Let's go back to the other screen and let me refresh it. So here also I can see Git repository, and when I click on the GitHub repo, let's see what does it show. So you can really click on this folders, and here if you click on triple dot, copy path, copy into worksheet and download. So if you have to copy this content into worksheet, let's see what this contains. Let me copy it. Now this entire content is automatically copied with date and time. Now when you click on this branch, it is showing all your feature branch here listed, including the main branch. And if the main branch is selected, then it will have a tick mark, and you can click on this fetch button and it will try to fetch if any changes are available to your repository, which we will see how you can also do it through the SQL command. So here you can see I have a total 3 branches. I have a 1 tag. This is a very powerful feature which Snowflake has provided, and you don't need to always go back to your GitHub account to check what is the state of the file and everything. Now one interesting thing, you can also download the content. When I click on the Git repository detail, this is how the screen looks like. So the ownership is with account admin, and here this is API integration, and this is the credential used, and this is the origin. You can hover on this and it will show you the complete path, or alternatively you can click on the copy and it will copy your origin. So we have configured private repository. We also understood that we need to create 3 different objects. One is a credential object, another is a API integration object, and finally we have to create a Git repository object, and understood what is the must and optional parameter. Now let's quickly create a reference to a public repository, and obviously it may not require a credential because you can simply do it with API integration. This is my new worksheet where we are trying to create an integration with a public repository. And since it is a public repository, we don't need to create any secret object. So let's repeat the process what we have done earlier without secret object. So this is my DemoDB public schema, and I'm using account admin role. Now first I'm going to create an integration object. And if you look into this integration object compared to the last one, where we have this allow authentication secret parameter available, but in this case I do not have any secret object. So I am just creating an integration object without any secret, and this is my prefix, and this is the name of my GitHub account. So this got created successfully. And next I am going to create a new Git repository first class object which is called my GitHub public repo. And here if you see, I am passing only the API integration name which is matching with this name, and this is the name of the repo. And if you would like to know what is the name of the repo, this is my public repo, but let me show you in my GitHub account. So this is my public repo, and let me go inside this. I have only one readme file, nothing else. This is only for the demonstration purpose. Let's go back to our Snow site. I have copied the name. So my GitHub public repo created successfully. Let's run this SQL command to see all the Git repositories available under my demo public schema. So now I have 2 Git repositories. Here if you see, the repository which is private is using secret, but the repository which is public is not using secret. Now if I run show git branches in Git repository in my public repo, let's run this command. So I have only main branch, I do not have any other branches, and this is my code commit hash which should match with my GitHub. So this is my commit detail 6CF7398. This is also 67F7398. Now let me list all the files which are available in the main branch, because I have only one branch here. And this is my readme file. Looks good. Let's see how my public schema looks like with 2 repositories. So now I have these 2 repositories available side by side, and one is public repository and another is that private repository. If I click on a definition, something went wrong, invalid object type Git repository, and let me try with this one. This is still in a public preview, and maybe these things will get corrected over a period of time. And if you would like to see in a new tab, let's see what does it show. It comes to this page, and here you have to change the role. So I will change the role to account admin. and then only it will be visible. So we managed to create public repository as well as private repository. We also managed to see the main branch and the feature branches, and we have seen some of these SQL command which are applicable to these new objects. And we have also seen how a repository stage looks like, which is a different kind of stage which is not directly accessible but works very similar to internal or external stages. Now let's quickly understand different kind of privileges applicable when it comes to this Git repository object. And this is very important because Git is primarily for the collaboration, and if you are not setting the right privileges for your Snowflake user to use or a read or a write, then it will not make any sense to create these objects and leave it in isolation. So my profile is having account admin role, and this is my database demo schema public. Let's go to the Git repositories, and here I'm going to work on my private repository. So this is my file explorer, and it will list all the files which are available in my Git account for this particular branch. Now let's click on this Git repository detail, and here the owner of this Git repository is account admin, which is the current role also. Now if you want other role to have access to this repository, then you have to add privileges, and for that, let's say I want a public role to have read and usage privileges. So I can select read and I can select usage, and let's also select write, and let's see what happens. So I can click on grant privileges. So it says if granting write must grant read first, if revoking read must revoke the write first. So this is an important thing. I was under impression that Snowflake should take care of this. Let's follow the instruction. So here I have given the read first, and I can also give usage privilege. Now fail to grant privilege received error SQL compilation, use read and write instead. Time this web UI doesn't work very appropriately. So we understood that usage privilege or write privilege does not work. So let's give the read privilege, and I have granted read privilege. Looks good. Now let's switch my role to public role. Now when I go to the public role, I am not able to see anything. Primary reason that I am not able to see, because whenever you allow a role to access the Git repository object, you should also give the usage access to the database followed by schema. Otherwise it won't be able to access the Git repository object. So let me switch my role and let me go back to the demo. I will give usage. So public role gets usage privilege. Let's do it for schema too. Now public role got access to the schema usage. Let's change the role to public and refresh this. Now I can see no data found. Let me refresh the entire thing. Now I can see the Git repository, and I can click on my Git. Main branch is enabled, so I can click on it. I'm able to see all the branches. I'm able to see the tag, looks good. And if I click on the repository, I can also see all the data. Think that this fetch is disabled, in the sense you cannot run a refresh or synchronization. And for that, do I need write permission? Let's try that out. Going back to account admin, Git repository detail, and here I'm able to see fetch. Let's go and give write privileges. Now public role has read and write privileges, and let's see whether the fetch button is going to be enabled when I switch my role to public role. And let me refresh this. So here this is my current role. If I go to the file explorer, now fetch is enabled. So if you want your team members who are assigned to a particular role within Snowflake, and if you want them to refresh the repository, you need to make sure that they should have a read and write permission. But does it mean that they can go and overwrite or change the file within the Git repository? No, this is not possible. We'll talk about it when we come to the limitation section. So we have understood what is the read and write privileges, and if you try to assign write before read, it throws an error. Usage privileges is not yet applicable in the context of Git repository object. And if you want to give read write permission to your Git repository, you also need to give usage privilege to the role, usage privileges on the database and schema to that specific role. We also see with this RBAC that the fetch button is enabled, which is nothing but a synchronization, and that synchronization allows you to pull all the changes which are available to a particular main branch or a feature branch to your Git repository internal stage. And if you do not give the right permission, the fetch operation doesn't work. So that is the purpose of those two different access which are associated with the Git repository. Now let's do one quick thing, that we are going to create an internal stage and see how the internal stage differs from your repository stage within Snowflake. So this is my new worksheet called stage, and here we are going to create an internal stage. Let's quickly run this. So I am changing my context. So this is my account admin role, and this is my demo public schema. So here I'm going to create an internal stage. It is created, and let's run this show stage. So this is visible, and if you look into that, this is type internal, looks good. And if I click here and go to demo inside public, so Git repository is also nothing but an internal stage, and I can explicitly create an internal stage. Here you can upload the file. However, you cannot upload the file here. This is going to be synced with your Git account, right? That is a core difference between these two internal stages. However, Snowflake does not say that this is an internal stage, but under the hood, this is a stage, because when we were playing with RBAC, it clearly showed that this is an internal stage and you cannot give a usage grant to the internal stage. So we understood Git repository stage and how it is different from internal stages, and we also have seen synchronization and read-write access. Now we are going to see how you can run different SQL commands on this Git repository, and what we have seen through Snowsite, we'll try to perform the same thing through the SQL command. Let's quickly see the important operations and command which you can do it through SQL. So this is my SQL command worksheet. I am using account admin role, and this is my context. If you have to describe a repository, you can run describe Git repository followed by repository name. Let's quickly run this. And here it will show you the name of the repo, your database schema under which this repo is created. If it is having an integration object name followed by the credential name, and who is the owner, what is the role, and if you have a comment and last operation. Now if you have to display all the branches which we have seen through our Snowsite web UI, so these are all the branches, and this is the tag. Here also we can see the branches and the tag. So if I have to fetch this detail via SQL command, I can run show git branches followed by in Git repository and the name of the repository. Let me run this. So here I have total 3 branches, and this is the commit hash. Can I do it through the public role? Let me try that out. So I change my role, and let's run this through the public role. So yes, this is possible. Let me switch back to account admin. Now if I have to get all the content from a branch, let's see how can I do that. So here I can run list command because it is an internal stage. Copy this feature branch and replace the value, and let me run this list command, and I can see all the files which are part of the branch is available. Let me go and add one extra file, and let's see how does it fetch. So I'm going to this Snowpipe branch and just adding one file. Now here I have given S capital, and now let's try to list this branch, and this time v6 should be part of the result. So here I do not have the v6. The primary reason that we have not run the fetch. We will run the fetch command and come back to this ls statement. Now if I have to get all the tags within the Git repository, so this is a tag, and if you notice my warehouse is still not up. All those commands which we are running as a git command does not need any virtual warehouse. Now here I can copy this tag name, and I will replace it and list all the files within that release tag, and these are the file which are part of this release. So this is an interesting thing. Now if you really need to fetch files for a particular commit, you can use this commit hash. So if I go to my commits, this is a commit on a branch, but I can copy this commit branch and I can replace it, and let's see whether it fetches the files within that commit. It is not available because I have to run an alter command, but I will come back to that. Let's say I fetch this commit. So I got all the files which are available in the repository for that commit. Now here I can run this fetch command, and this is from our Snow site web UI, but if I have to run the fetch command using SQL statement, I can run an alter statement which says alter git repositories my GitHub repo and fetch. And for that you must have the right access to the repository object, otherwise you won't be able to do that. So let's do that. So here it says branch feature Snowpipe, and it is fast forward, and this is how you also do it when you run your fetch statement through VS Code or any other Git based CLI. Now if I try to run this Snowpipe feature, let's see what happens. I am able to see my Snowpipe SQL file available, looks good, and this is my SHA. Now if I copy this commit hash code, whether I would be able to run that commit command or not. So I copied this and I replaced, and let me rerun. Now this worked for me. So if you are having any error, make sure that you run this alter fetch command and retry those statements not running. Now let's switch my role back to public role, and let's see, can I drop a repository? Now I'm just trying to drop my public repository. So this does not have enough rights or authority to drop this object. So switching back to account admin, and let's rerun this drop statement. Yes, my repository is dropped successfully. And now if I run show repository, I won't be able to get the detail. So I have only one repository, which is my private repo. Looks good. Now I'm just showing some alter statement through which you can change some of these repo parameters. So if I have to add a commit, I can say alter git repository and name of the repo, set keyword, and the parameter is comment equals to value. So this is done. And if I say describe my repo, I would be able to see the comment here. Looks good. So I'm going to create a tag called team tag, and this is having following values. Now I'm going to alter my Git repo and attaching team tag equals to HR here, and let's see what happens. So my tag statement executed successfully. Now if I try to describe my repo, let's see whether I would be able to see the tag or not. I'm not able to see the tag. If I go and refresh this page, let's see if I can see this tag through my Snow site web UI. So since it is object level information, I have to click on Git repository detail, and here I am not able to see the tag information. What if I run a show Git repository command? Will it show? Let's try that out. So this is my show Git repository. Show Git repository does not show the tags also. By running alter statement, you can change API integration or a Git credential if your credential fired and you generated a new credential. However, you cannot change the origin. There is no alter command to change the origin. If your origin changes, in the sense your entire Git repository object itself is changing. So you can change API integration, Git integration, but this part cannot be changed. You can add comment, you can add tag. So those four parameters can be altered, but origin cannot be altered. So we have covered how you can run different SQL statement to describe the parameter of an Git repository stage object, as well as how you can change the parameter by running an alter statement. We also see how you can run the synchronization, and using that synchronization, you can fetch the latest changes available in your branch or feature branch or a main branch. And while running SQL statement, we also notice that you cannot change the origin when the repository object is created, and other parameters can be changed. So far, we managed to read different information from our Git repository via Snowflake SQL command. Now the next, how we can run those SQL script in our Snowflake using execute remote file command. So let's go back to our Snow site. If I have to run a specific file from my repository, I need to give name of the repository stage followed by feature branch name followed by the path of the SQL statement. So I can go to the main branch and let's see what this file does. So this is just creating a simple table and creating a file format, creating a stage. It is running a copy command and running a stream object. So let me run this execute immediate from this Git location. So here it says I have some issues, syntax error. Okay, so here there is a problem. And let me commit it. And before I do something, I will make sure that I run this fetch statement. Now this is main branch fast forward. So my inventory table created, and if I refresh it, I can see a table, inventory table created. Now let's run another statement. So my CSV file format created successfully. Now what if I try to give, instead of uppercase, small case? So it says that it is not found. So it is certainly a case sensitive. So I need to bring it back to capital S and rerun it. So my internal stage got executed. Let me refresh it so I can see my file format created. So we have seen how you can use execute immediate statement, and since Git repository stage is an internal stage, you can really pick the file and run it. However, if the changes are available in your Git repository, make sure that you run the fetch command, which will pull all the fresh files from your Git repository, and the appropriate SQL statement will be executed. Next, we will quickly see how you can create a stored procedure by referring to the Git repository file location and create this object without writing a lot of code within your Snowsite web UI. Before we go and explore how you can create a stored procedure by referring a file in your Git repository stage location, we are going to populate some data set into inventory table. Let's see how many tables do I have. So this is my inventory table. Let's describe this table. So it has total 4 columns, ID, column 1, column 2, column 3. And I am going to insert this record into this table. So total 5 record got inserted. And let's say I want to write a procedure which returns all the inventory belongs to column 3 value hello05. So this is what the result I expect from a stored procedures as a result set. So I have created a stored procedures named filter by column value, which takes the name of the table and the column value, and it returns a result set where ID, column 1, column 2 and column 3 values are returned. It is written in Python language. Runtime for Python is 3.8. Package is, it is using Snowpark, and it is importing demo.public.mygithub repository, branches, main branch, Python script and filter.py, and this is the handler. If you are new to the Snowpark and would like to learn more about Snowpark, have 2 dedicated lists for Snowpark. You can watch both the playlists to get more deeper understanding about Snowpark. Let's go and check what this filter.py does. It does nothing. This is the name of the function, and this function is being called by passing the table name and column value, and here it is performing a filter operation. So this statement creates table object as a data frame, and on the data frame we apply a filter, and here we say column 3 value equals to this column value, which is nothing but this parameter. And if I come back to this stored procedure, this is the filter.py, which is available in this Python script location on my Git repository as import, and here this is the name of the function. I have just added some sample, I just added some modification, and here also I will make some minor modification. I will just change this file. So both the files are committed on the main branch, and this is my Python script filter.py, and here I have another v7 script available. Let's go back to Snowsite. Since I have made minor modification, I would first run the alter statement, and my main branch fast forward. So this is refreshed. Now I can run the list command. Now here I see Python script filter.py, and here this is my v7 create sp. I don't need to run the filter.py file. It is not required. What I'm going to do, I am going to simply execute this v7 create sp.sql, and this script is referring to this Python file through that import package path. So once it is created, now let's execute it. Since it is a Snowpark based stored procedure, it generally takes longer than expected. When I come to this database explorer, all the procedure object, and this is the procedure which is available. Looks good. Now let me call this procedure filter by column value. Instead of 5, let's give 4. Now I got the result which is matching with this value, and if I click on this view query profile, here it says extension function called, and this is what the statistics denote, that this is a Python code which executed under that stored procedures. So if you have a lot of stored procedures, whether it is a Python based or a non-Python based, you can really use the power of execute images statement and make your CI/CD pipeline fully automated through this approach. So we have covered how to run SQL statement from the remote location. We also understood how to create a stored procedure by referring a Python file which is available in your Git repository. So far, a lot of interesting thing has been incorporated with this integration. However, there are many things which doesn't work. So one thing which does not work, Git integration with Snowflake allows you to read the content from your Git repository. However, you cannot make changes to your Git repository file, or in other way we can say pushing code back to the Git repository is still not possible with the current version of Git and Snowflake integration. Current Git repository stage is still in a public preview, and it may be available as a GA in near future. Access to the Git repository from Snowflake is supported only over public internet. You cannot have a private link based Git integration. Repository object is not a shareable object, which is another limitation. You cannot create repository stages inside application packages, which is not yet supported. You cannot create repository stage inside your native application. That is another limitation as on today. And when you are accessing files from the repository stage, it may work slightly slower compared to your internal stage files. Though there are some limits to Snowflake's Git integration, this new repository object will change how we data engineers build data solution with Snowflake. If done right, it will make us more efficient and super productive. I hope you have enjoyed the topic covered in this video tutorial. If you have any specific feedback, please leave your comment in the comment section below. If you want to go further and learn how to do this Git integration with GitLab or Bitbucket or AWS Code Commit, or want to use Git with Snowflake Notebook, check out my Git playlist on this channel. I hope you got something valuable from this video. If you did, please hit the like button. Your support not only recognizes the work behind this free content, but also helps others to discover this playlist. And if you think it can help someone else in your team, feel free to share. Thanks for watching, and let's spread the knowledge and growth together.